Welcome to the Dynamic Competition Initiative podcast, the podcast that explores the dynamism and complexity of innovative systems. Our mission at DCI is to develop and advance innovation-based dynamic competition theories, tools, and policy processes adjusted for nature and the pace of innovation in the 21st century. Our goal is to benefit society and the maintenance of an open, democratic, liberal order. My name is Thibaut Schreppel. I am one of the co-founders of the DCI, run as a joint effort by the European University Institute and UC Berkeley. I am an associate professor of law at the Free University of Amsterdam and faculty affiliate with the Codex Center at Stanford University. My colleague for today's interview is Bo Hayden. Bo currently splits his time between UC Berkeley and Chalmers Gothenburg University in Sweden. Today's guest is Professor Brian Arter, who is currently an external professor at the Santa Fe Institute and a visiting researcher at the Intelligent System Lab at PARC. Professor Arter is a unique interdisciplinary thinker that combines knowledge of operation research, economics, mathematics, and engineering to better understand the nature and impact of technology on society. In particular, he is well known for his work on increasing returns, complexity economics, and technology evolution, all of which are critical to our understanding of our changing society in the 21st century. More information on Professor Arter's career and scholarly work is available on our website at dynamiccompetition.com. Thank you for sharing your time with us and insight today, Brian. Brian, today we'd like to talk about two issues of mutual interest: economic theory on the one hand and technological change on the other, and in particular, the development of AI and digital economy. Even though these are interrelated topics, as we will discuss, I'm sure, we will start with a discussion of your recent essay on economic theory. And here, I'll let the floor to Bo. Bo, over to you.
All right, thanks, Thibaut. It's great to have you today, Brian.
Thank you.
Well, I'll start out with your recent essay on economics in nouns and verbs. It's just a wonderful description of what I would call this epistemological challenge we have in developing economic theory and that models reality, which is, I know, something that you're concerned about, that models need to really be able to be linked to empirical reality. You know, it reminds us that that what we see depends on how we see it. Could you provide us a little background on your concept of nouns and verbs and economics and why you wrote the essay?
Sure. I found that in the last 5-10 years, I got fascinated by the whole idea of computation, and I began to pursue that, reading or maybe rereading Alan Turing's 1936 paper and trying to figure out what computation really was. And I came on this question, what can computation do for economics? And that led to other questions. Could computation ever be regarded as economic theory? So I started to ponder standard economic theory. I'm an alum of Berkeley, I'm glad to say, and that's where I learned a lot of my economics. But the atmosphere when I was studying economics at the PhD level in Berkeley was that economic theory at that time, the early 70s, was changing and becoming super mathematical, meaning it was formulated or beginning to be formulated in theorems and proofs and in very rigorous, for my taste, far too rigorous mathematical language. And pretty soon people began to think of economic theory as mathematics itself, almost as a branch of mathematics. And I'd been heavily trained in mathematics by that time. And I began to wonder, as an outsider in economics, why that should be. It seemed to me that the economy was very large, it was vast, it was subtle, it was enormously interactive, yet it was being reduced to what you could stuff into equations, what you could just sort of take and shovel into fairly small systems of equations with the idea that you could do logical manipulation of these and thereby understand issues in economics much better. I think it was partially successful. I read Samuelson's Foundations, and Samuelson, more than anyone else, was the person who wanted to see economic theory as being highly mathematical. One of my professors was also Gérard Debreu, and he was very much in the same camp. So there were a lot of technical people at the time trying to reduce economics to a form of mathematics where you could have axioms and theorems and implications and thereby understand the economy. I started to look hard. This is where the paper Economics and Nouns and Verbs came out. About 2 years ago, I started to look pretty hard at what economic theory really did, and I realized it was based upon the mathematics. It was based upon not super modern mathematics. It was largely algebra, linear algebra, and different forms of calculus. And when I looked into what that was in general, I realized that you could only, if you're doing algebra, x plus y equals z, or 5x plus 53y equals k or something, the x's and y's had to be quantitative nouns. And then I began to realize that if you think mathematically about the economy, everything you deal with must be quantitative nouns. And I began to suspect, I'd wondered why in economics there was so little idea of process. Everything, even in the kind of language we use in everyday economics on television, is about nouns. We have prices, indices, rates of unemployment. We have quantities produced, numbers of unemployed, numbers of firms starting up, rates of everything, all nouns. And I thought, where did the processes go? And I began to realize that if you accepted the doctrine that theory equals that sort of mathematics, then theory had everything in economics you dealt with had to be expressed in nouns. That didn't feel right to me. So that's where that essay came from. That I'm a theorist. I'm not against economic theory. I'm basically, more than anything, a mathematician. But I like to query things, and I didn't like the idea that everything should be reduced to quantifiable nouns. So you have, I remember taking courses in economic development at Berkeley, and and economic development wasn't really well defined. As an engineer, it seemed to me to be very much something that was driven by events, by processes. In fact, the reason I was studying economic development, I became a development economist early on, was I was from Ireland, in my case, Northern Ireland. And at that time, economics of developing countries certainly applied to that part of Europe. So I was interested in it, but it seemed to me that there was something wrong. The definition, is development happening? Development itself wasn't well defined, but an economy was supposed to be developing if its GDP was increasing by at least 1% per annum. And it struck me at the time that's like saying you can reduce all of embryology. How does a fetus develop? A fetus is developing, providing it's growing in volume, maybe in number of cells, more than 1% every 2 weeks or something like that. It didn't capture development for me. I'd been in India, I'd been in Turkey and Bangladesh and written about these, and somehow it just seemed to me 95% baby had gone down, had been thrown out with any bath water, that none of this captured development. So that's really the motivation behind this particular paper.
That's what I found so interesting, is that it's intuitive, right? Even though the world of economics and algebraic mathematics, as you say, seems very technical, and it seems on the surface to be, done properly and correct. There's this intuition as you live life that something's missing, as you said, like a book that's only written in nouns. So I thought that was a good way to kind of to summarize this intuition that many people feel working in the real world, but also trying to work formally.
I think you're absolutely right. The real world is full of events and drama and processes. And if someone is developing themselves, say from age 12 to age 20, going through puberty and teenage years and going from being a child to an adult, essentially, we don't measure that just, with their height against the wall or something like that. We realize that there's deep psychological changes, physical changes happening. And it seemed to me that all of those were left out. So I began to wonder, how can we get them back into economics again? I want to add one thing as well, just by way of the story. I remember showing up for the third semester of a year's worth of economic development economics at Berkeley. And the professor walked into the room on the first day, and he wrote, he was a theoretical economist. I won't give any names here, but a very well-known one. Put a squiggle E, capital E, on the blackboard, as those were used then. Said, let squiggle E be the space of all economies, and let squiggle D of squiggle E be the space of all developing economies. And I sat there, probably in the back row. I was puzzled, flummoxed. I thought, has this man ever been in a third world country? Has he ever set foot in India or Indonesia or anywhere that's developing? I listened to more of this drivel for about half an hour and stood up quietly and just walked out. And that finished me with, not with economic theory, I'm a theorist, but with trying to understand economic development through squiggly and squiggle D. I could tell you many, many episodes like that, but it seemed to me, even in those days, and it's a good while ago in Berkeley, that really what I was craving was thinking about the economy and really understanding it, not just here, but at the abdominal level, at the gut level, what's going on. And the people who had more of that field were economic historians, and really good ones, and sometimes people who understood human behavior. I remember being in a finance class in Berkeley, and the professor was asked, some hand went up, and the professor was asked, Professor, how do you know why? How do people decide as a matter of policy to come up with new taxes? How's that settled? Waiting for a theoretical answer, and the professor just said very rightly, "Oh," he says, "that's like a brawl in an Irish pub." He says, "If you see a head, hit it." And I mean, it was meant to be funny, and it was, but there was more truth in that than in all the theorems that I was trying to take on board.
And so, listening to this story, one won't be surprised that you then started to work and were one of the first to work on complexity systems and complexity theory. So I'm wondering, what's the train of thought? What's the relationship between your work on complexity theory and your more recent work? Because you mentioned that it's been just 2 or 3 years that you've been worried and trying to do research regarding the verbs also on top of the nouns. So what's the logic behind?
Yeah, yeah, I got fascinated by complexity. That's a longer story, and after I left Berkeley, I did a lot of work in developing economies. I became a demographer. Eventually, in fairly short order, I took up a chair at Stanford in population economics. And somehow, still a longer story, got involved in looking at complex systems, nonlinear dynamics, and became one of the very early people at the Santa Fe Institute, which started around 1984. But really, its first research program was on economics. This was 1988. And I ran the program. I was very lucky to be brought there, in my case, by Kenneth Arrow. We had a lot of superb people there, many of whom knew no economics, whatever. So we could start with a sort of blank slate.
Yeah.
So to answer your question, my version of complexity, everybody in that field has somewhat different definition, but what I find useful is that complex systems are ones in which individual elements are somehow reacting or adapting to the pattern they create. That sounds a bit abstract. I find it helpful to think of cars on a fairly crowded freeway, say in California. Each individual car is creating a pattern. We call that pattern traffic. And each individual car is adjusting itself to the immediate local traffic pattern around it. That sounds pretty simple, but that's the way complex systems work. A complex system could be ions in a spin glass if you're a physicist, or they could be B or T cells in an immune system. But in all these cases, these are individual elements adapting to the overall pattern they create. And it seemed to me very early on, and a number of other economists, that the economy qualified as a complex system. And indeed, we'd sort of thought of that since Adam Smith on. Individual elements, or we call them agents, as you know, banks, consumers, producers, investors, in their own arena, shipping companies are adapting to some pattern they are together creating, maybe via trading or exchange, or and the question then, the fundamental question, all of economics, and it's been this way for 250 years, how do individual agents create some outcome? And you'd like to ask the question, how do they then adapt to that particular outcome and thereby change the outcome? Economics took a shortcut about 1870 and decided, this is when algebra and calculus were really coming in big time. Economics decided to take a simpler approach and say, okay, in any given issue we're looking at in the economy, how does individual behavior create an outcome where there'd be no incentive for that individual behavior to change? So you get this nice equilibrium circle. Agents together create an outcome. There's no incentive to change. And to make that mathematical, we began to assume, I wasn't around then, amazingly, but economists began to assume that the agents were all alike in whichever part of the economy they were looking at, just to simplify things. And they knew that other agents were the same as them. They were perfectly rational, so we could predict how they would react or optimize, and they would together create some outcome that was in equilibrium. It was a super simplification. I think it was necessary. I'm not against it, but that gave us equilibrium economics. The type of economics that I've been interested in and took a lead, I can claim, in developing and gave a name to it, complexity economics, is very much relaxing those assumptions. So we assume that there are agents still in the economy, banks or investors, whatever, creating some outcome that they have to react to. And they react or adapt or change their strategies. That recreates the outcome, and they have to keep doing that. That may settle into an equilibrium or may not. So I remember talking a lot to John Holland early on. I said, you believe that strategy and chess play, which he knew an awful lot about, is at equilibrium? He said, oh God, no. He said, grandmasters now could easily defeat grandmasters of 150 years ago. I said, why? Are they smarter? He said, no. But the knowledge of strategy has moved. And so there isn't really an equilibrium in games like chess or checkers or Go for that matter. It's not that people are smarter, it's just that what's known is shifting. And so complexity economics emphasizes that. But if you adopt that outlook, then you're dealing with people trying to make sense of the situation they're in. You don't know exactly who the other agents might be or how smart they are or what resources they have or what techniques they have up their sleeve. So you're dealing partly in a situation of fundamental uncertainty. You don't know. And in that case, as an economic agent, you're generally trying to figure out what's going on and where people are coming from, and you tend to be exploring, trying out different strategies, using hypotheses. I used to watch foreign exchange traders in Hong Kong at 3 a.m. I don't know why this fascinated me. And I'm talking about being in the trading room of a very large Western bank, 3 a.m, and they were always sort of saying, okay, wow, price just moved. I think the Central Bank of China has just come in. Well, hang on. I think the New Zealanders are there too. That would mean that. So this is the way I think that real economic decisions get made. And in your language, which actually thrills me, that's dynamic competition. It's not equilibrium anything. People trying to maneuver and make sense of things. And I think that's true generally in life. It's a good shorthand thing to say, well, let's assume there is no change, no call for change, things are at equilibrium, we can wheel up mathematics. In this other case, the variables keep changing if you wanted to do mathematics, the structures keep changing, the strategies, the descriptions of how variables are related to each other would keep changing. So it's hard to do mathematics. And in that case, we switch to computation.
That's what happens with the verbs, right? The verbs change the nouns. They get rid of some nouns. They change the nouns. They change. So that's what happens when you add the verbs. That's why it's easier without the verbs.
Absolutely. Well said. Thank you.
You know, and several times we went back to real life, quote, real world questions. And I remember reading the introduction of one of your books in which you explained that the only ambition you were given when creating the Santa Fe Institute and started working on those questions was to to work, and I don't recall how you framed it, but to work on something big, to work on something that would change the nature of economic theory. And I guess we can say that you achieved that goal in that respect. But I believe Bo have some more questions regarding
let
the
me
use of
just
models.
let me just comment on that, Thibaut.
Yep.
Yeah, we 1988. I was running this group, the first research actually at the Santa Fe Institute, and it the portfolio was to look at the economy as an evolving complex system. And I had some super smart people, including John Holland and on and off Arrow, Frank Hahn, on and off Tom Sargent and others. But these were really smart people. Stuart Kaufman was another theoretical biologist. But to the life of us, we weren't quite sure what we should investigate. How did that work? And in the end, I remember phoning Ken Arrow at Stanford. This was before email, it was quite a while ago. And said, Ken, what do you think we should be doing? He said, let me call Phil Anderson, who was his partner overseeing that. Phil had a Nobel in physics and super smart guy. And Phil called John Reed, who's, I think at that time was chair of Citibank, and they were funding us, our little project. And the word came back. Ken called me a day later, and he said, well, the word comes back from John Reed. Do anything you want, providing it is at the foundations of economics, and providing it's not conventional. And I nearly dropped the phone. I couldn't believe it. I couldn't believe my good fortune. And it reminded me of something historical. I thought, this is a bit like, it's 1520 and the Augustinians in Wittenberg surrounding Martin Luther call the Vatican, and they say, we're interested in theology. What do you want us to do? Where it goes back to the Pope and whoever that is, and whoever that is, Pope Leo X, maybe, I don't know. But anyway, the word goes back to the Pope and and comes back to Luther's people. Do anything you want in theology, providing it's not conventional and at the foundations. So anyway, this thrilled me, and we had a pretty good mandate. And what we decided to do was look at some of the standard problems in economics, but in each case loosening the assumptions that neoclassical economics made. We needn't assume rationality. We needn't assume everybody knows enough about the problem to. And so we discovered we had to start to investigate using computation, and the idea that people were not just learning some parameter, but learning the dimensions of what the whole problem was about.
That's great. I mean, this fits well into my next question, because so first of all, just the story of getting the, how do you say, the blank check of digging into economics and rewriting it the way that you see it. I think that's you don't get that very often from the powers that be.
No, not from God.
So, and of course, that's a little bit of the issue, isn't it? I mean, you have such strong people. You need, if you want to break these Keynesian paradigms, you need people that say it's okay, that people would normally not say it's okay. What they say, it took Nixon to go to China, right? So you have to have the kind of people that are willing, the people, when you start to say stuff, they look at them and go, are you okay with this? And they're like, yep. Like, okay, then we can go forward. So
if I may say something here, is a really beautiful irony was that just about more than any other theorist of of the 20th century, Kenneth Arrow,
Mhm.
developed and was responsible for general equilibrium theory with a small number of other people. But he was the doyen. He was the very much the dominant figure in that field. And yet it was Ken who encouraged us to look at the economy as a non-equilibrium system. I thought at the time that that was extraordinary. And now 30 something years later, and Ken's no longer with us, I think it is extraordinary. And I think that shows more than anything the largeness of Ken's set of ideas and his approach and his generosity.
We were reading a paper recently that Ken Arrow wrote later in his career, and he talked about these older theories that need to be questioned, that we're not sure about, and then he cited himself in his theory, right? And then you're thinking, okay, well, that's good. That's someone you can trust, right?
Definitely dominated. He and De Bruijn and a few others dominated theoretical economics in their generation, but Ken was very open to moving past that.
So when we talk
So
about
I'm
these,
sorry I interrupted you.
no, go ahead. So when we talk about these squiggly E's and D's and the simplifications under the heading of what I call, all models are wrong, some are useful. I guess that's the argument, right? That we could look into the complexity, but we would still need to simplify it, and the models that exist simplify things and are good enough. So why would you say that we need these broader economic frameworks? How would an algorithmic model, what would that allow us to do that the other models don't? And do we need this more now in the world, the dynamic and the rate of technical change that we're facing in the 21st century? Do we need these more now than maybe before? Could we have gotten away with less perfect model before, but not necessarily now?
I think that's an excellent question with a huge amount of parts to it. So let me see if I can.
Yeah, I put a lot of questions in the question there. Sorry about that.
That's his trick. Yeah. And if I may add something, because something you mentioned already quite a few times, you were saying, well, maybe at the time it made sense, actually, right? I mean, why not in the 50s believing that it was possible to put everything into nice equation? Well, it is not the case, but we tried, and maybe it was good that we tried. So it was a way to complement both questions. But please.
Well, just to comment on that, on your comment, I'm not against neoclassical economics. In fact, I would say I'm for armchair theorizing of very wise people who know the economy. I'm for using economic history to give us deeper insights. I'm for neoclassical economics, providing we're aware of its limitations. Economic psychology, there's many approaches, and so I would reject the idea that there's any approach to theory that is, well, to use an academic term, privileged over everything else. Mm-hmm. I think, to go back to your question, Bo, I think it's much more, why is a broader or a different framework needed? Why bother? One attitude you could take is this neoclassical approach is fine. It's very publishable. All sorts of textbooks talk about it in depth. It makes great logical sense. So, why?
Why open up the box?
Well, why march into the Greek temple at night, smoke a lot of cigarettes, leave cigarette butts on the floor, and disappear, and expect the high priest to be pleased when they show up in the morning? I think that I thought a lot about really how to do this new framework with my colleagues at Santa Fe and many other economists as well, including Alan Kerman and Don Farmer and others, really good economists thinking more or less along the same lines and not at Santa Fe. But sometime around 2012, 2013, I was writing a paper on this framework of what's called complexity economics. And I began to realize that in economics as a whole, the broader field of economics, there are really two main questions. I don't mean technically, but there are two main questions. Ones that I would call questions of allocation, that's one class of questions. And the other class I decided was a class of formation. So let me explain those. Allocation questions are what's produced at what price all across the economy, how do prices form, how do they arrive at an equilibrium, who gets what. And so that covers in theory of international trade, it covers general equilibrium theory, it covers classical game theory. You know, if you have many different parties interacting, who should get what, or how will that work out in terms of allocating rights or allocating payoffs? How does international freight shipping work? Who is given the costs and where freight starts and finishes up? How do prices form and quantities shipped form, etc. So it turns out those are questions that have to do with prices and quantities largely. Therefore, by my earlier reasoning, you can reduce these to questions of nouns, and those nouns are interrelated in some way, and you can use algebra to great effect. So those whole class of problems, allocation problems, all across economics, were mathematized extraordinarily successfully, extremely well understood. Even theories of monopoly, theories of imperfect competition were reduced until you made it into a proper allocation problem that you could well define mathematically and use algebra and calculus, etc., to solve those. And I think that's all to the good. But then there's another class of problems I realize that I call problems of formation. How do economies develop? If it's true that 80% of economic growth, Bob Solow showed us as long ago as 1958, if 80% of economic growth is not due to growth in labor or growth in factories or capital, it's due to technology. So the economy is basically creating or forming out of its technologies. What's a technology? How do technologies develop? Where do those come from? How do technologies form? How do institutions form? How does economic structure change? What is structural change in the economy? It's pretty clear if you have an economy in 1888 in the US that's largely agricultural, or in Europe as well. And 40 years later, it's based upon mass production and automobiles and broadcast radio and all sorts of other things. What happened? How does structural change work? It's not a matter of quantities and prices. It's a matter of the underlying ways in which economies themselves work. Now, all those questions of formation largely depend upon forming new ideas, forming new technologies, and undertaking new actions. How do I'm a small startup, say in Silicon Valley. I'm going to give myself the name Google and whatever, 1990s, and I want to get into the search engine field, and I've got a good algorithm. So how does all that sort of formation work? Where does innovation come from? Where does invention come from? And those are all questions of formation. You're dealing with new things. It's not just you're dealing with X, Y, and Z. You're dealing with X, Y, and Z, creating K, L, and M. And that's not easy to fit in or shoehorn into standard algebra. So you're dealing with things, and it's much easier to look at those as processes driven by events. And so this whole field, I realized, of economic formation that was thought about certainly by Joseph Schumpeter, quite hard, and very much thought about by Thorstein Veblen and many others who were subsequently sidelined in this noun-based theory. That whole area got pressed to the side. It got pushed aside by theorists because they couldn't mathematize that in any believable way. And that was left to economic historians, some of the very best people who knew about technology were economic historians. That was the case at Stanford.
Nate Rosenberg, for example. Yeah.
Nate Rosenberg, Paul David, these were all these are economic historians. They knew a lot about technology. And this is very odd. We have historians telling us how the economy forms and grows. Well, why not? They know how that happened historically. But those questions of formation got pushed aside because they didn't suit algebraic mathematics, and they got dropped, and they fell into disrepute, and they have been, I think, amply well looked at by historians and others in a kind of wordy way, but there was no theory. So economics, weirdly enough, if it's true that 80% of growth comes from technology, then you could ask, where does technology come from?
It's strange in a way, isn't it, Brian? That, like you said, Solow, he kind of, put a number on the size of our ignorance, didn't he?
Yeah.
And that still wasn't enough. When something's a residual and it's 80%, is it the residual or is the other stuff the residual?
Yeah.
And so you think that would have kind of been a Copernican moment, but it didn't seem to win the day, really, and we're still talking about it. But it would obviously, you would have to believe in the 21st century, with everything that's happening, that the formation part of economics has to start to take the lead.
Absolutely. And I thought at the time was very interesting. At the time I was studying in Berkeley, very much neoclassical economics, I was sort of shown that neoclassical economics was a big area, like a table, a big set of things. Some are in a tiny little area in the corner, a little subset where parts of the economy that didn't fit that very well. Things like, how do institutions form? How does invention happen? And these were tiny exceptions you couldn't easily reduce to neoclassical economics. Now, years later, I realize, take your percentage, but I would say that these questions of formation occupy at least 50% of the space or more of what should concern us in economics. But that would vary with taste. But given that we've no theory of technology, or didn't have until recently, or no theory of invention, no real theory of structural change, if something's changing in structure, you can't nail it down to structure in the first place and then proceed with changes in the amounts of things in that structure. So our economic development, we're lacking theories in all those areas. And the insight I came to for this essay was you're not going to get theories until you open to process and events, verbs.
And so you've been one of the first to work on those questions when it comes to technology, and I think, and that's also something that I've seen you that you've been quoting quite a few times, John Holland. If it's in equilibrium, it must be dead. I like that one very much. And by the way, for everyone listening to us, John Holland was, if I'm not mistaken, the first PhD in computer science in the history of the United States, which
Yes.
is very impressive on top of all the rest. But so focusing on that idea and starting from that premise that we should study formation, especially of technology, you've been introducing a distinction between what we might call the Darwinian process of how things evolves. So it could be species and varieties, but also technology, how if you have a smartphone, how you get a better camera and then a better connection and a 5G, et cetera, et cetera. But then you said that something different, which does not happen in the state of nature, may happen with technology, which is a combination of different technologies coming together and creating something which is not entirely new, but new in its form, such as the airplane, such as blockchain, and et cetera, et cetera. And so my question is, but you've been mentioning already the fact that we have now some more work coming and we've made some progress. Which kind of empirical work do you think we need still to this day when it comes to documenting the formation and the combination of different technologies for the creation of new technologies? And here we do have to talk about policymakers and regulators. Do they have a role to play? And if so, which one?
I started seriously to look at technology. I'm trained as an engineer originally. I've had 4 years in a UK university of very rigorous engineering and nothing but that, if you throw in a lot of mathematics, and then grad school after that. I became fascinated by what technologies are and where they come from. And in the 1980s, as I was working on increasing returns and looking at individual technologies, why, for example, did VHS succeed where Betamax recording system was supposed to be better? I started to look more deeply into technologies, and I began to realize that all technologies that are created from pieces and parts, or more generally functionalities, things that do things, and they're put together from those. So the steam engine, when it gets going, if you look at it, say in 1781, when people like James Watt were still concerned with it, then you begin to see that steam engines had boilers, they had some sort of chamber or cylinder, they had pistons, so they could transfer steam energy, the energy in steam, to a piston, which might move some sort of a wheel. And you began to see, or I began to see, all technologies like the steam engines having parts, cylinders, pistons, cranks, gears, wheels. And when the steam engines transferred to railway locomotion and becomes a central part of the railway locomotive, I realized that a locomotive, which was a novel technology, before that they used horses, even for carriages on rails. The locomotive, say in the 1820s, consisted of a steam engine, which consisted of parts, and it had wheels and it had rails and so on. All of those technologies existed before the railway locomotive. All those bits and pieces existed before the steam engine in its turn. So I began to realize that, and looking into this very deeply, all technologies were fathered by or parented by existing technologies. I'm standing here in Xerox PARC in Palo Alto. Quite a while ago, in fact, about 50 years ago, PARC invented the laser printer. People at that time were wondering, how do I get an image on a computer, say like a photograph you could project on a computer screen, to print? You can't do it very credibly or easily by using these big line printer typewriter affairs of the day on that sort of big rolls of paper. How do you do that? And there were various suggestions, but Gary Starkweather, who's an employee here at PARC, or was, came up with the idea, a fairly simple idea, but very hard to get to work, that maybe you could use a computer processor that understood what the image looked like to direct or control a laser beam that could be finely focused, and the laser beam could paint, in the jargon, the image itself on a Xerox drum inside a Xerox copier. And then you crank the drum and the rest is just copying machine xerography. So every technology I started to look at was a combination of existing technologies. Lasers existed, the actual optics that Starkweather had to use to make this work existed, computer processors existed, xerography existed. I thought maybe there's exceptions. No, they're all put together from existing parts for a very simple reason. Invention is basically solving a problem. How do you print images you can see on the computer, text maybe? How do you detect enemy aircraft in 1936? It's, if you're in England and it's possibly coming from the continent to bomb you. These are all problems, and we fish into what we know to solve them. And what do we know? We know existing technologies. So in the case of radar, in the 1930s, people started to say, okay, you know, we can use a new principle. We can get very high energy, high frequency electromagnetic beams and point that in the right direction. And there'll be some distortion of those, maybe an echo, if there's something metallic coming 30 miles away, and maybe we can detect the echo. But to make that work, then you have to look at radio circuits, you have to look at existing systems or ones that could be brought about from existing systems to create the high energy, high frequency electromagnetic beams. You would need detectors. All of that then is brought out of existing technology. So let me be very careful here. So I began to realize that invention, there is a theory of evolution for invention, but for radical inventions, it's not Darwinian. It's not a matter of you can vary radio circuits till you're blue in the face. You're not going to get radar. You can you can try varying steam engines randomly. You're not going to get a locomotive out of that. These come about by how a novel technology is always responding to some perceived need, and then using whatever Lego set you have at your disposal to construct something to take care of that need. So invention is problem solving. It requires problem solving many layers down. It's not magical. It's not necessarily the province of geniuses. It's really the province of people who know an awful lot about technology. So I wrote a book based on this called The Nature of Technology, what it is and how it evolves.
Yeah, I was about to mention that. That's mandatory reading for all my students, and I think it should be for everyone in the field of law, economic, engineering. So please go ahead.
I think you're very wise. So anyway, but I began to let me see if I can get this into a kind of syllogism. The economy is created, and I really mean created or formed via its technologies. Take away all the technologies that have been invented in the last 700 years, you're back in the 1300s. Maybe we could have textiles and hooded cloaks and cathedrals, but everything in the economy, everything else disappears. You have flocks of sheep and goats and whatever. So the economy is created by its technology. It's that those technologies build out themselves in a self-creating way. Novel technologies like the steam engine become a building block for further novel technologies like the steam locomotive or steam engines that run whole factories. And so technologies form a collective where some technologies, not spontaneously, but with the help of engineers and people solving problems, are combined to create novel technologies, and they're thrown back into the Lego set of technologies to become building blocks for the creation of further novel technologies. And I call that type of evolution combinatorial evolution. And it's a mechanism for evolution. We all often forget that Darwin's mechanism for evolution, which is variation and then selection over a long period of variants that are more suited to their novel environment, that is not evolution itself. That's a mechanism for the creation of novel species. Darwin only mentions the word evolution once, I think, in his Origin of Species book. What he's really concerned is how do we get new species? That's the problem he thought he was solving. He's credited with evolution, but evolution goes way back to the Greeks or specifically to Darwin's grandfather and others in the 1700s. What I was concerned with is if economies form from their technologies, where do the technologies come from? Quite often we get new technologies as variations and selection Darwin style of what's out there. You know, when locomotives did appear, they started to appear in different engineering variants, and Darwin style, we quickly learned what worked and what didn't work. So there's always an element of variation and selection, but really radically novel technologies, anything, say, from blockchain to Bitcoin, if you like, to AI, are formed from what already exists. And if that seems unfamiliar, just think of really programming a computer in a computer app or program you're trying, let's say, to do something, sort numbers or sort text, whatever. You're using constructions, subroutines, if you like. You're using procedures that have worked in other programs and other applications. So those procedures rely on sub-procedures that have worked. And those sub-procedures rely on elementary operations of software and computers. And then below that, there are hardware circuits making all possible. So again, you've combinations built from combinations built from combinations, right up until you get something, say, in the 1960s, like Quicksort, which is a very heavily used sorting algorithm. But then quicksort's tossed into the Lego box, and sorting algorithms are a routine that's very much used in other applications. So I began to realize that what we call libraries of functions in computation, every C++ would have its own library, so would Python or other computer languages. Those are combinations using that language that are set aside, and then you can use in a Lego set or a library, and then you can fish those out and use them for whatever you want to create. So a friend of mine at Fuji Xerox Palo Alto lab, we were working, reduced that to an algorithm. I think we called it a library of producing a library via combination of useful objects, and we patented that. So I have a patent on the algorithm, which pleases my inner engineer, but if not my economist. And you were, can I just make a comment then on your question? You know, how do you empirically look at this sort of thing, and what does this mean for policy?
And what do we need? Yes.
What do we need? I have to tell you, confess right up that as an economist, I've never been much of an empirical economist. I'm not against that. It's not my temperament, and I've never been someone who looks much at policy. I think that's a bit down the road, but let me try to give you an answer here. I think that once you get this idea of evolution by combination, I think that at least for empirical work and for teaching, it'd be very, very, very good to ask students or professional economists who want to understand technology to go back to some technologies and figure out what are the other technologies that made that possible and where do those other technologies come from. You can do that empirically, but you need to do something to do that economists haven't done much of, and that is you need to break open the black box. You need to go inside the black box and figure out what it is. And I think because we neglected technology very much in economics, we treated every technology roughly as a black box. What is a computer modem? I remember being at a seminar discussing the economics of modems in the days we used those, 1980s, 90s. And nobody thought of asking how a modem worked. And off record, I will tell you that two economic historians were in the room, and so we who were previously mentioned. So we were off the record, but so what I would like to see empirically is not so much confirming that theory. I don't feel I need confirmation unless I haven't seen any exceptions. I don't believe there are any. And because every technology is parented by the other technologies that make it possible. If there are exceptions, I haven't seen any yet, any more than computer programs that don't use existing things, even if it's only addition and subtraction. What I would like to see, though, is an awareness of what's inside technologies. And the empirical work that I would find very useful is looking at a technology. It might be artificial intelligence, might be deep learning. It might be photonic transfer of information, and I'm trying to think of what the more standard word for that is. Fiber optic technology.
Mm.
Okay, so what I would like to see is economists thoroughly understanding, opening that up and saying, how does it work? How do you do multiplexing fiber optic cable, meaning how do you transmit a lot of different conversations on different frequencies on the same cable? How does that work with satellite systems? If 80% of an economy at any time is created by technology, why not understand technology? Why not take individual technologies and understand those? You don't have to be an engineer, you don't have to design those technologies, but you bloody well better understand how they work. You could be a doctor doing diagnostics, maybe in the whatever 1500s, tapping people and bleeding them or whatever was done at the time. But we didn't make much progress until we opened people up and we saw how heart valves worked and how the liver worked and what happened if you had kidney stones or a ruptured appendix. So open up technologies. If that's what you call empirical, I'm all for that. You're really starting then to understand where an economy comes from.
Mm-hmm.
The other thing about policy is that I don't have much to say. Not because there's plenty to say, but again, temperamentally, I'm not the right person. I'll just say that. So you guys, I think, are better positioned than me to answer the question. But I would say this, that as I began to understand technology better and where it comes from, I began to realize it comes from clusters of really smart people.
Mm.
And why should that be the case? Well, it seems to me technology isn't based on science. Totally, to some degree it is, if it's sophisticated. It's more like cordon bleu cooking. If you don't know how to do something, and I'm standing in Xerox Park here, you go down the corridor and you find someone who does know. And you get this idea, I think I could do this at that temperature if I could get this in place. But didn't they try that 2 years ago? Walk down the corridor again. Oh yeah, we did try that. Didn't work. Let me tell you what does work. So clusters of people who truly understand the use of functionalities, how things work, is really the key to progressing in technology. It's not necessarily using big companies like Siemens in Germany, really great company. It's more if you have clusters like in Bell Labs, or for that matter, Xerox PARC, or if it's science, which is a form of technology, the Cavendish Lab 100 years ago in Cambridge, trying to understand how the newly discovered nucleus worked and electrons and things like that. Clusters of people who can talk to each other and who become experts in the functionalities, how to use technologies and how to combine them. This shouldn't be abstract because we take for granted that if you want to do cooking at the very high end as a chef, you better spend a lot of time learning with a group of high-end chefs, possibly in Milan or Paris or Shanghai or somewhere. And it's much the same. Technology isn't quite a form of cooking, but it is, because it's about combination and understanding. I could achieve this if I could put that in place, but to put that in place, I need to get there. So it's like doing Sudoku, and that's all pushed ahead much better if we have centers where there's an awful lot of people who know about that and who can pass it on. You can't quite just put that in a research paper or a handbook and pass it around. It's really, I think, doing technology. It's very much like doing good theoretical science. It's an art, it's a skill. I call it deep craft. It doesn't exist as quite as logic. It exists more as experience. So when Charles Townes invents in around 1950 the maser, which was the predecessor of the laser 10 years later, he was looking at atomic resonances, nuclear resonances, and out of that comes a radio frequency oscillator that gives you very pure waves and so on, more like a laser, but at a radio frequency. When Charles Townes invents that, I checked to see, and I read a lot of what he'd written, and behind what he had done was 30, 40 years of experience in looking at molecular frequency, molecular resonances. And so you don't get that sort of stuff coming out of genius. You get it coming out of a lot of experience. I was very amused to see Kary Mullis, who got a Nobel Prize, as I think Townes did. He invented the polymerase chain reaction, the one that's used to multiply DNA. And he saw all the pieces and the parts to put that together. It's really how do you replicate DNA from a few strands up to billions. So, and he said, well, he was driving on Highway 1 here in California in a sports car, tried to explain it to his girlfriend. She fell asleep in the passenger seat. So she didn't last too long after that. But Mullis commented later, I couldn't believe it was so easy. And then he goes on about all you had to do was to take, I've even forgotten the jargon, it's in one of my papers though, hybrids, was the hybridization of two primers. I can't quite reproduce this, but and I'm reading this, I think easy, but it's easy just as it would be for a top level chef. This is not difficult. All you have to do is create a certain sauce of this type and then precisely at this temperature. And we wouldn't say that's genius. We just say that's great experience. And invention is very much in that department.
Well, I can't help myself but to offer three comments, three quick reactions. The first is that indeed, that's what I had in mind when mentioning empirical work, not only because you may indeed understand which technologies are coming together and are being combined to create a new technology, but also this might be a way for you to understand the evolution in a more Darwinian way of that technology, because depending on the components and the old technology being used, the dynamic capacity of two technologies might be different. So you might want to compare the car and the train, in the 50s, and then compare the two in nowadays and see that the evolution has been way different, potentially because they invent technologies which are different in nature. So that's my first comment. The second one, I just had a parallel coming, and I know it's a weird one, between Darwin and Satoshi Nakamoto, who wrote the Bitcoin white paper, because he's indeed not mentioning blockchain, such as Darwin not mentioning evolution except for one time. But Satoshi is not mentioning blockchain at all in the Bitcoin white paper. And he is actually mentioning quite a few computer science previous work, such as DAI, B-Money, or Merkle for the Merkle trees and so on. So it's very obvious that it was a combination of technology. And the third comment is relates to what you said, the clusters of expertise and the people coming together. which of course is really hard to put, in equation. But that always makes me think about those tea time events at universities where people come together, and the importance of all that, which is something that we do not do very much in Europe, maybe a bit in the UK, but I'm not aware of any similar events and type of rituals in France or Spain or the Netherlands. But it might be something we may want to work on.
Well, I could say cattily that you have to have good tea. So if you know how to make tea, people will flock around. In the UK, technically I'm a UK citizen. We don't do good coffee. So I think that there's, to be more serious, a lot of interaction. And I didn't really answer your question very well. What about what's good government policy? I think good government policy is to have places like DARPA. These are clusters of people who really truly understand technology. Bell Labs, to foster clusters where technologies are extraordinarily well understood. It's kind of a bit laissez-faire, a bit more laissez-faire in the US than it should be. If I go to China, which I do, I notice that there's more of a feeling we want to get up to speed in fintech or in whatever blockchain. So, and maybe this is more industrial, we'll cram 500 people into a small building and let them interact like crazy. So I believe interaction and fostering the knowledge that you already have. And just very quickly pointing out that I do not want to emphasize that evolution and technology is Darwinian. You mentioned that every technology does spin off into different directions, and there's quite an element of Darwinian evolution by Darwinian mechanisms. But I think we've had enough of that point of view in technology, and I think we should get down to how real technology does progress. And again, it's even in development of a technology, it's pretty heavily combinatorial. You can get very good aircraft engines working, as a standard internal combustion engine using gasoline or something close to that in the 1920s. But then you can take you can do fuel injection, or you can have you can use pumps and you can combine those to make sure that you get fuel injected properly, say to replace the standard carburetor. So very often the combination itself changes. So pieces are taken out and new pieces are slid in. And as a replacement, again, that's combination, but it's not Darwinian. It's not that the same thing is quite evolving, or maybe you could argue about that.